Eric Burgess here. A survey was conducted on 1,000 randomly selected people, and it was found that 30% had chocolate as their favorite flavor. Find the 95% confidence interval of the true proportion of all people who has chocolate as their favorite ice cream. Also, if you want to comment down below, at Wendy's, are you a chocolate person or a vanilla person? I'm pretty hardcore chocolate, but I've seen some good arguments for vanilla. All right, so let's go ahead and jump right into this. So first off, we've got to identify the problem, because I wrote the formulas here, but you wouldn't be given these formulas. You'd have to know to go and use these formulas. So the biggest giveaway for us is it says that it's a confidence interval right here. So we know it's a confidence interval, but there are three types of confidence intervals. There's the Z, T, and then there is the proportion confidence interval. So our second clue here as to what kind it is the fact that we have our study group and they tell us about a percentage of those people. So this immediately tells us that it's a proportion confidence interval because this is 30%, meaning that 30 out of every 100 people, because a percentage is just a proportion, 30 out of every 100 people find that chocolate's their favorite flavor. So if you had 100 people, 30 of them would say, oh, we like chocolate as our favorite, right? That's what they found with these 1,000 randomly selected people if you were to pick 100 out of there. And so we know that we're going to be using the proportion confidence interval. And so you would go and you'd look up this confidence interval, right? Because it's got the p hat, and so that's going to be the proportion of people that find chocolate as their favorite flavor. And then if you're given data, you would actually use these. Fortunately, we have the percentage directly. So we know that p hat is equal to 30%. That's the percentage of people that have chocolate as their favorite flavor. And we need to convert this to a decimal to use it. That's going to be 0.3. So all right, q hat, if we look at our formula here, is just 1 minus p hat. So q hat is equal to 1 minus 0.3, because that's p hat. That is equal to 0.7. So now we've got our q hat, we've got our p hat, and we're able to use this formula. Now there's another way to do this, and that's just to use the calculator. So let's go ahead, let's do the calculator way first, and then we'll plug all our values into the formula and use the Z table in order to do this. So in the calculator, we're going to go to stats and then to tests. And in here, we're looking for a confidence interval. So we're going to look for something that has to do with proportions and intervals. So we see we've got a Z interval. So we don't want that. We've got a T interval. We've got a 2 sample Z, 2 sample T. And then we've got a 1 proportion Z interval, which is exactly what we have because we're using Z scores here. So we're going to choose A. And in here, it wants our X, which is the same thing as our P hat. And so and in here, it wants our X. So we don't have X directly because we were given a percentage. And so we actually want 30% of this 1,000 people. And the way we can get that is we just take 1,000 and we multiply by 0.3. And that's actually going to give us 300. But if you have more complicated numbers, this can be trickier to do. So you could do it in the calculator, or you can actually type 1,000 times 0.3, and it'll do it right there for you. And it gives you 300. And then our N, well, that was 1,000. That was our total number of people. Our confidence level that it asked for, well, let's go back, let's read this, was 95%. So again, that stays the same. And now we just hit calculate. It calculates it. Wow, that was really fast. And this is our interval. So we would say the true proportion P is between 0.2716 and 0.3284. Or, in other words, the proportion of people that have chocolate as their favorite ice cream, the true proportion, is somewhere between 27% and 33%, if we do some rounding here. So this would be the way you would write your answer, and you could even write out a sentence saying that the true proportion of people who like chocolate is between 27% and 33%. Now, let's go ahead, let's do this using the formula. So in the formula, we've already got p hat, so let's just go ahead and write that in. So p hat is 0.3 minus, and now we need z of alpha over 2. So our alpha is whatever the confidence interval didn't consume, right? So we're 95% confident, and that leaves us with a 5% that we are not confident. And so there's a 5% here. That's our alpha. Now keep in mind this is a two-tailed test. Two-tailed, or a two-tailed thing. It's not really a test because we're doing a confidence interval because we could be wrong above or below. That's why we have stuff that is below the true proportion and stuff that is above the true proportion. And notice that we're starting with our proportion from our sample, and then we're adding or subtracting the error. So if we start off with our true proportion and we subtract off, we're going to be below it, and this is the error. And then on this side, we have the true proportion, and then we add the error. So this puts us above and below the true proportion. And the 95% comes in from the distribution, and that's going to determine our z value. So that's 5% with both tails combined. In one tail, there's going to be 2.5% because half's going to be below and half's going to be above. And so 5 divided by 2 is 2.5. So we're going to go on to the z chart, and we're going to look for 2.5%, because if we were to draw this out, if we were to draw it as a picture, it would look like this, and then there'd be shaded regions on both sides, and there'd be 2.5, or in this case we'd have to write it out as a decimal because this is a percentage. So there'd be 0.025 here and 0.025 here. When you put them together, you get 0.05, which would be this value, which is all our alpha. And now this area here in the shaded, if we want to find out the z-score that goes with that area, well, we look in the chart area to the left. We know it's symmetric, so we just take the positive and negative version, right? This would be the minus z, this would be the plus z. And so it would be the same z value. And so we only need to look up this in the chart. Now we're looking up the area, so let's go to the chart. We're looking up 0.025. So we go into our chart, and we look up 0.025. Now it's an area. Areas are in the middle, right? And the z-scores are on the side. So we look for 0.025. So here's 0.021, 0.026. Oh, look at that, right on the money. 0.025. Let me make it green right here. So if we zoom out some and just look at this, it goes over to 1.9, and then right here, 1.96. And so let's go ahead and write that in. So we go back to our table, and we say the z is equal to plus or minus 1.96. We do plus or minus because it's symmetric, right? So if it's minus 1.96 here, it's going to be plus 1.96 over here. So, okay, let's go ahead and do that. So that's our z of alpha over 2. So we're going to pop that in. So we have 1.96. And then we have the square root of p times q. So p hat times q. That's 0.3 times 0.7. Whoops, I wrote 0.9. 0.3 times 0.7 divided by n, which was 1,000. And that's one side. And then the true proportion's in the middle. And then we have our point estimate, which is 0.3, plus the error, 1.96. So here's where the positive 1.96 comes in. Then we have square root of 0.3 times 0.7 over 1,000. All right, so let's plug this in the calculator. So we're going to turn it on. We're going to clear it, 0.3, and then minus 1.96. And then we have a square root, so that's here in blue. So we hit the blue key, square root. And then we want a fraction. Fraction's in the green F1 menu, so we hit the green key and then F1. We choose the first option. That's going to be 0.3 times 0.7 over 1,000. That's going to give us 0.27. And look at that, 27. And then in this case, we have a little bit of a rounding difference, but that's totally fine. We are insanely close to this value. And if we round it to 4 decimal places, it's the exact same. So we get the exact same value. And if we do the same thing, if we just go up and hit enter while it's selected, we're going to come in here, change it for the plus sign, plus, and we get 0.3284, which is exactly what we have right here. And if we round it, so we'd get the exact same conclusion. A way to check your work: use the calculator, then calculate it by hand just to make sure. So that is how you do this. If you have any questions about this, let me know. If you're a Citrus College student, definitely swing by online tutoring, subscribe, and we'll catch you in the next problem.